Charleston, South Carolina, and spent a lot of time in D.C. And before coming to NOAA back in, I guess I've been with NOAA since 1997, I worked in South Carolina for a couple of the regional planning commissions, councils of government. And the last I worked for was the Appalachian Council of Governments, which is Greenville and Spartanburg. So we had a lot of interaction with the state of North Carolina. I'd say at that point we were somewhat envious at the state level. What you guys were all doing in North Carolina, we just weren't there at that level at that time in South Carolina. It was kind of interesting as I was walking in from the Marriott. I walked past a poster that advertised a meeting in the North Carolina Arbor User Group. And when I was in South Carolina back in the 90s, we started up South Carolina Arbor User Group, basically modeled on what we're going to do in North Carolina. And we had this idea of having a joint conference. And looking around, a lot of you probably don't remember the Praise the Lord Club, Tim and Jay Baker. You guys remember them? So that was only two, they had no funding. And at that point, they already kind of had this phrase, so we had this amazing, almost surreal GIS conference in their facility, and it literally looked like they got run over the building. On the stage, you went back around the stage, the table, they had the box for the food that they were supposed to eat during the show. So I just had lots of really good memories of the interactions with North Carolina. I've always thought of you guys as leaders. My home office, you guys might know, used to be called the Coastal Services Center. And when we started back in 1995, 1996, we did a lot of work with the North Carolina Center of Geographic Information. It was old Navy, who's now at AECOM, who's to NCCIA, Tim Johnson. So there's just one of the reasons I was able, other than proximity, to take part in this conference is just really thinking of the state of North Carolina. You guys have an access to it. So what I'm here to do today, 25 or 30 minutes out of that, is to try to give you a broad overview of what we're doing within NOAA using GIS. Okay? I'm not going to be able to get into anything in great detail. Hopefully, I'll share some things that I'm aware of, and I encourage anybody to either get in contact with me up here afterward or follow on through. Sorry, they just brought this in. All right, we might need to. Sorry, old school technology. So the first thing I want to do, I have a federal employer know, so I do have to issue a disclaimer up front at the beginning of this talk. So slides on. There it is. All right. So although I am an employee of NOAA, and the National Weather Service is part of NOAA, and that I plan to discuss some new exciting National Weather Service GIS activities, unfortunately we don't have any control over the weather. And I do feel really bad because anybody who's ever had any role in putting on a conference, I can only imagine what Greg and the other folks were doing when we started issuing our weather forecasts, 5-day forecasts, 7-day forecasts. And we started looking at the projections and thinking, oh my God, we've got all those people traveling, and everything's just. So to go to the next slide. Anybody wondering why I got these? So you can't see it back because it's somewhat small. So that is the space shuttle. There's our two astronauts doing the spacewalk and nice view of Earth back and behind. And the reason I put this up is to make a point. The astronaut on the left is Dr. Catherine Sullivan, who is the NOAA administrator. So she's the head of NOAA. She's the top of our agency. And Dr. Sullivan was actually one of the original 6 female astronauts back in the 1970s. Was the first female astronaut to do spacewalk, and was also on the space shuttle mission that launched the Hubble Space the reason I bring this up is all of us in the room, we all work for someone. And how much effort you guys spend educating and communicating on the value of GIS, and arguing for budgets, and arguing for mission. I'm really fortunate. We don't have to do that in NOAA. I mean, she gets GIS and mapping and Earth observation. She's got a perspective that is unlike really just about anybody sitting on the planet these days. So we are really, really fortunate. So next slide. With that, though, Dr. Sullivan has challenged us to become what she is calling leaders in environmental intelligence. And that's her definition: timely, reliable, actionable information that is pertinent to real world lives. She wants to know what to be an international leader in this area. Now you have to understand, this is somewhat of a staggering number. NOAA creates or collects 20 terabytes of data per day. It's not gigabytes, it's not megabytes. It's terabytes of data, day after day after day. And her kind of charge to the organization is how do we turn that data into environmental intelligence that is going to make a difference in the issues that society is dealing with. Let's go to the next slide. So here's just a list of some of the, I'll call them environmental intelligence assets. These are some of the things that are creating all that data. And I should note there, NOAA literally maps from the bottom of the ocean, hydrographic survey, to the surface of the sun. Solar weather forecasts. That entire column, we have a very large geographic scope of the work that we do. We are given the authority of Congress to be responsible for 10 different satellite systems, 3 buoy networks, 120 weather radars, 200 plus tide gauges, 17 ships, 10 aircraft, and ships with hydrographic survey, and fisheries surveys, 5 supercomputers. Those guys are pumping out models, weather models, climate models, those national climatic data center. Human observers, we extract them to marine mammals, and birds and turtles, and track them as part of our work. This is where that 20 terabytes of data comes from. Just you see me looking down, I've got my computer that's not connected to this computer. So I click it, this is what it's doing. So this, if you dig a little bit more in this kind of environmental intelligence arena, there's a production side and there's a demand side. And I'd argue that everybody in the room can kind of see themselves as both sides. So the production side is we are all collectively dealing with incredible changes in observing, networking, repeating scientific analytics solutions, right? And I'm sure a lot of times you guys are inundated with some of the information that you have access to. What's the good stuff? How do I use it? And you're trying to figure out, on the NOAA side, you're trying to figure out how to turn that into environmental intelligence. Where's the good science? You guys might be doing this government intelligence or business intelligence. We're all kind of dealing with the same challenges and opportunities on the production side. On the demand side, we're also on this, we can kind of relate both in our professional experiences as well, personally, right? People want, they need and want, right? What people need and want, that's what we are trying to meet. People want to be able to customize their experience. Right? And transfer hyper-localization of personalization. I've got a 16-year-old and a 14-year-old, and it's amazing to me the way in which they interact with technology, what they expect from the technology. I'm almost 50. That's a completely different life experience for me from what they're doing. So how do we deal with all that data? Not surprisingly, I'm a geospatial guy. I think geospatial is a huge part of the answer for how NOAA deals with this 20 terabytes, this environmental intelligence. I argue that the technologies that we have access to, stuff that you all use and we use, can provide that framework for the collection, the storing, and the analyzing the percentage of our environmental intelligence. And some of you are probably more familiar with NOAA than others. These are just some of the data sets that we're responsible for. So geodetic control, everything away, right? All we do in GIS sits on top of the geodetic control framework that is responsible for nautical charts, the base map, the framework for the oceans. Any ocean-based, find me an ocean-based application that doesn't have a NOAA raster nautical chart as an background. I'd be shocked. Shoreline, topography, marine habitat, fisheries. So these are some of the products that we try to create, some of the kind of subject matter expert areas that we work with. NOAA has 4 mission goals. It's just standard for a federal agency to have strategic plans and goals that we're working toward. Ours are weather-ready nation, healthy oceans, coastal resilience, and climate adaptation. I could literally show you hundreds of apps, data sets, citizen support tools that are supporting the efforts that we're using at NOAA with our partners to address these critical strategic priorities. All right, so this is kind of a pause slide. So I've been talking for a while. You guys have a little bit of an idea of some of what we have in NOAA. So let me just kind of step through what this means from my perspective and how we manage our geospatial. So we've got a huge diversity in our user communities and their requirements. Right? From climate scientists to fisheries managers to coastal managers to local surveyors. They all have different needs and wants. We need to work with a huge variety of data. The data types, the formats, 2D, 3D, 4D, grid, NetCDF. I mean, it's crazy the number of data sets that we work with. We have both operational systems and we have a hell of a lot of legacy systems that we have to continue to support. There's a huge operations and management costs associated with those. We're a big mix of commercial and open source software. On the GIS side, we do have an ELA with Esri. We are finishing an ELA with Google. Primarily, many of you are probably aware that Google's kind of changing how they're working with their geospatial product suite. Big user of open source. It's huge in the oceanographic with that community, meteorological communities, open source. Multiple development environments, fragmented IT infrastructure. We have 102 certified FISMA, that means in the Federal Information Security Management Act, IT systems. 102 IT systems in NOAA. Every single one of them is basically a unique entity. Even sharing data across parts of NOAA can be a pain. So, how do we try to make sense of this from a data management or a geospatial perspective? Not surprisingly, it's not really a technology issue. It's as much a data management issue. So if you kind of work your way up in the bottom of the graphic, so the data sources, think back to that environmental intelligence slide that showed the assets. Those are basically all the data types, generalized. And then you work your way up through habitable formats, vocabularies, data documentation, metadata. NOAA has been a huge proponent of metadata. Linda Wayne, I don't know if she's in here, Linda Wayne has been working side by side with us in the FGDC and Schaefer for years in metadata. It's the religion. Data access services and APIs, I'll talk a little bit more about this. Data search and discovery, I'll talk a little bit more. But this is how we kind of make sense of that diversity or chaos I'll show you in just a second. This is a really ugly slide, but it was a PDF. It was the easiest way to get it. Again, this is not technology. This is how do we put in place basically the standard operating procedures for the best practices for the NOAA data management community. So things like data management plan. Every NOAA data set is required to have a data management plan. Archiving, data documentation. You've got to document your data using FGDC or ISO. You've got to put it into a NOAA catalog so it can be discovered. If we put money out in grants, the grantees are required to make data and basically document what they do. The one that's not on here that I think is going to have a huge impact, I was speaking with somebody before from the DENR. NOAA is a scientific organization. We have a lot of scientists. Government scientists are not that much different than academic scientists. The awards are oftentimes based upon publishing, referee in journal material, things like that. There's been a huge, I believe, problem for federal agencies, especially science-based agencies, with government-funded research and the geospatial data that comes out of that oftentimes is not made available in any timely fashion. 2 years ago, Office of Science and Technology Policy, OSTP, White House level, put forward a requirement that all agencies are required in a timely manner to publish research results. It's the PAR Act, Publish Access Research Results, I think is what it stands for. Just yesterday, we approved the NOAA policy, which means now that if a fishery scientist goes out and does a trawl, and in the past has been able to sit on that data for 10 years, but the Fisheries Management Council wanted access to it, because you need to make a decision now. Hopefully, some of that data is going to become available soon. So I think that's a really good thing. Kind of shifting gears a little bit now. I'm going to walk through a little bit more the nuts and bolts of some of the things that we're doing in NOAA. You kind of think of the graphic that we showed before. We kind of stepped up. I'm going to hit on multiple elements of that. First is related to data documentation, metadata, cataloging, access, search. We have stood up, some of you may know this, something called data.noaa.gov. This was a requirement. I'm hoping most folks are aware of data.gov. Maybe not. Maybe it's a bad thing. It's not so much a state thing. So we know we have a NOAA version of that. We have a NOAA Geo platform. We'll talk a little bit more about GIS online. And then we do specialized data access. The Climate Explorer itself was actually work that was done through Gregson at EMAC. And it's helping NOAA make some of our climate data available to some of the broader White House initiatives. So this, the take-home message from my perspective is NOAA puts a high value on data documentation via metadata and making our data discovery. So if I had been up here 3 years ago, I probably wouldn't even have talked about services, or it just would have been, and we're also kind of doing services. Now, it's all about the services, and it's about the standards that basically, standards support the services, right? I think as an agency, we put our money where our mouth is. We are a principal member of the Open Geospatial Consortium, active participant in many of the standards development and testbed activities, especially in our domain, oceanographic, meteorological. There's a number of other standards for the meteorological organization that we know through something. But the fundamental shift in NOAA to making our data available as services, as web services, RESTful data access point. APIs were, I'm guessing many of you, or some of you, many of you might be ahead of us. We're just beginning to really develop more and more APIs. It's a huge push, again, from the White House. It's just enough, it's kind of an extension of that open data paradigm, right? First put it out there, document it, look at it all download it, okay, put it as a service, make an API available so developers can work against it. We're not doing anything crazy here. I've got popular service types, not surprisingly, Esri, GeoServices, GeoJSON, OGC. A couple of areas that we're, I don't know if I'd say we're struggling with, but we're definitely working on. Service descriptions. You know, we've got a great standard, a couple of standards for metadata for data. We haven't yet figured out and know exactly how we want to document our services. So that's something that we're kind of trying to figure out. Performance monitoring tools, service health. We literally have some groups that know if you ask them that. So how do you know if your services are working? Well, if they're down, somebody calls me. And that's really not an acceptable way to find out if your services are, are up and working. So, and I know there's some tools out there that we're beginning to explore. And then service registries. We could not live without the base maps that we got access to through both the commercial and the open source community. Originally, and for years, we were Google Maps API. It was fundamental to the migration of the weather service into kind of a GIS, more GIS perspective. This last year, though, again, because of some changes that Google had, and the fact that we got Esri DLA, we moved to the Esri base maps. No, I'm sorry, folks. Again, I've got two. So look at the third bullet in the number. We 2 to 3 billion map transactions per year is the kind of scale that we're dealing with. So if we had to basically develop that kind of in-house service, map service, just think of the infrastructure that we have to have, and being able to partner with Google or Esri. The biggest load, that's the Raleigh-Durham Weather Forecast Office. You might not have noticed that map is an Esri basement. Every time somebody goes to the Weather Forecast Office, you're clicking one for the NOAA account. We use ArcGIS Online. On the one hand, this hasn't done exactly what I thought it would do. I thought it would be more of a way for us to get our data services out there. It's not really, the staff and NOAA are not really jumping on it. They love the story maps. We have people all across NOAA developing story maps. I think it's great. No one's quite showed me yet what the benefit it is. People are enjoying that one. That's good. In terms of tools, we do almost no desktop development. Maybe some office automation type stuff for GIS, but really it's all internet and mobile. The JavaScript, API, mapping tools are probably the same ones that you're using. One thing we are trying to do, though, is make sure that we're documenting this as well as possible so that developers like you can try to access NOAA data. We do still do those in decision support tools. I wanted to put a Burma application because I think it's a really good example of a very complex decision support tool. This is the Deepwater Horizon. This was what's called common operating kitchen that was used by NOAA, Coast Guard, and BP for sharing information. It's entirely open source, pulls data from a number of different groups, and they're really reaching out to their user community to basically take code from Burma and use it in other applications. On the mobile side, again, kind of like on the APIs, we're not probably where we need to be yet. We're doing stuff with responsive design, absolutely. We are building more and more mobile websites, mobile-only websites, and then we are beginning to develop some of our own apps. I've listed a couple of them up here. Not a whole lot of app development, though. Where we're seeing more of an impact on mobile is folks like you guys using our services, especially private sector, for their own apps. And not surprisingly, the two biggest services we know most popular are weather and nautical charts. And I'm going to end here kind of on visualizations. Because the NOAA data can be somewhat complex and time-dependent, we try to find different and hopefully innovative ways to show, let's say visualize our data. So this is sea level rise impacts here. This is Charleston. This is not a lot of houses. That's good. And I'm just going to step through here. What we're doing is we're rising 1 foot of sea level rise each time I click. And you can begin to see, and then the customs house in the bottom right-hand corner, we've basically figured out what the base elevation of that is. As we flood, you can begin to visualize what that impact is like. So that's kind of cool. Greg, you might need to punch on the computer for this. And then some of the data in NOAA, especially the Earth system models, we've got to go outside of our normal GIS tool set. So this is an example of a Earth systems model using those global forecast systems, and it's a typhoon. And what it shows is how a typhoon hitting the coast of Japan actually ended up causing a heck of a lot of rain and bad weather in Alaska and the western coast of Canada. Is this GIS? I don't know, but it's definitely a good way to make people aware of and educate them on some of the other things. And let me just close this part here on some of our challenges. We struggle, the government, the federal government struggles with the use of cloud. On the one hand, the White House says, cloud first, cloud first, cloud first. You've got to go to cloud, you've got to adjust for cloud. On the other side, you've got the IT security police telling you can't do that, or they want to so customize the offerings that the Amazons and the Microsofts want to put out there that either private industry says it's not worth it for us, or it becomes so costly that it's just not worth it. We're losing the benefit. Complying with the multitude of IT security government policies is an issue. Shockingly, in NOAA, we can't use GitHub. And we can take part. Greg, and EMAC has a GitHub repository. We can participate, but we can't actually have our own GitHub. So again, this is a lot of times, at least on the government, federal government side, the new technologies, the new innovation, the implementation lags because of some policy considerations. And then soliciting feedback from users. We literally can't, without jumping through an incredible number of hoops, even ask people what they think. So we've got to find as many new and creative ways as possible. So let me just end with a couple of things that are coming up. So for many of you, as Greg mentioned at the beginning, weather service, right? Everybody wants weather service data. We always have a booth at the Esri International User Conference. I bet you 95% of the people come by want weather data. How can I get weather data as GIS services? So we've gone from text to graphics. We're in the process, and I'm really happy to let you guys know that we are smack dab in the middle, if not close to completion, standing up a true enterprise-scale IT infrastructure, initially for weather GIS data, and eventually for the rest of the NOAA GIS data. What this means, you have to understand, operational in the weather service in NOAA means something fundamentally different. Our web farms in NOAA have to be designed to handle the load of 2 concurrent hurricanes hitting major municipalities at the same time. When Superstorm Sandy was going up the coast, East Coast, we were registering on NOAA web pages 600 million hits in total. Now, you can't imagine GIS would have that same load. We've got to build the infrastructure that when we say we're blessing it as a weather service, NOAA, geospatial service in its operation, it has to meet a number of criteria. Full infrastructure in College Park, Maryland, and Boulder, Colorado. Contracts with Esri for our GIS server, with boundless scope and geo, and development, QA, and production tier. Re-engineering the workflows, this is probably the most complex element of this. We'll still be putting out the text and the graphics and all the other formats. But we need to be also basically another thread where we're putting out OGC services. So what we're going to be doing, so the first phase, which will be in March, we were talking about our big meeting. Some of you guys might know Malcoast. It was an application that was actually developed from the NOAA Office of Coast Survey. A lot of the chart people to help their folks to do basically coastal modeling. And the guys internally in Office of Coast Survey started realizing how challenging it was internally to get access to NOAA weather services and so they built an application. They started showing it to people. People were, wow, that's sweet. So we rolled it out as a public product. It will be the first application that is moving to the, it's called the Integrated Dissemination Program, IDP. That's the infrastructure for weather service GIS. When it moves over, not only the application will be at that operational level, all the embedded services. So that's a big deal. I'm going to skip this in the interest of time. It just showed how, it showed ocean currents and just some of the neat ways we visualize them. The second phase, hopefully by the Esri User Conference, we're going to say in fall, will be all of these additional services. Many of these are categories or classes of services. They will also be on the weather service IDP infrastructure. So for many of you, especially the emergency management community, that are currently, I was at the National States GIS conference yesterday. I talked to a guy afterward. He was telling me how he was using a weather service that somebody from some municipality was serving, but then Esri we're serving it for them, and when because we know have been doing a good enough job ultimately in doing our work. And the hope is very shortly here there will be services you guys can come on, which I think is really, really important. So bring us back around that environmental intelligence. 20 terabytes of data NOAA gathers each day. 2 terabytes of data is what we say we release. You don't get caught up in the numbers. You just kind of look at the scale. It's also order of magnitude, right? So what are we doing though? In February of 2014, we released an RFI, a request for information, with 70 companies. You guys would recognize the names of 50 of them. Many of them were consortiums of data. A tremendous amount of interest. And here's what people think. In the private industry and in academia, they fully believe that there is data that NOAA has that they could get access to. There would be, on the private side, additional, basically products and services that they could offer, and on the academic side, additional research. So what this means is, let's say NOAA runs a weather forecast model, and we put the forecast out every 10 minutes, and we might actually be running that model every 2 minutes on the supercomputer, but we basically only give you guys the slice at every 10 minutes. Right? The thought is that we're able to create these data alliances, which are basically relationships with the major cloud vendors, and we know the names. If we can work out a relationship that is at no net cost to the government, where we either push our data or they pull it from us, and that they're able to basically co-locate all this NOAA data that we're not currently making available with the computing, the analytics, and the storage that the big private weather and a number of other groups would be interested in. We think that this could be a real win-win. Taxpayers are paying for this data that NOAA's creating and not distributing. Private industry believes there's jobs and economy benefits. So I think it's a really good thing. And I think it speaks to, let me just close with this. Wrapping back to Dr. Sullivan, there is no doubt that as a global society, as a U.S. society, we are dealing with a tremendous number of children. And NOAA, because of some of the areas that we have a leadership role in, we really believe that we've got to step our game up when it comes to making data and science available. For this audience, from my perspective, I just really fundamentally believe that GIS and geospatial services are going to be at the absolute forefront. So with that, we say again, thank you guys very much. I am NOAA. I have nothing to do with the weather. I just say thanks. And I hope you guys have a great rest of the conference. Unfortunately, I've got to head back to Charleston later this afternoon. But yeah, this was great. I really enjoyed this. I think it's lunchtime. But seriously, if anybody's interested, I'll stick around up here. You want to come and talk?
Yeah, in the interest of time, we'll just continue you all have questions every time you come up. And we'll get into the box lunch hour there. So with that, we'll conclude the session. Thanks for coming out this morning.
Can I ask you the question?
Ask me a question?
Yeah, the hydrographic data, where do I get that?
Well, that would be a question for him, yeah.